Let's talk about performance tunings for Zammad in the current version 6. This video will help you if you already experience performance issues like slow loading user interface already. Of course, it may also help you with a better dimensioning of your system. This guide should be seen as an orientation, but may not always reflect your scenario if some of your configuration would usually be considered a bit over the top. Please note that not all versions may come with the mentioned environment variables we're talking about today, so make sure you're running a current version of Zammad. To the moment of this video, this would be zammad-6.5. We will also only reflect PostgreSQL installations. If you're running on MySQL or MariaDB, please consider migrating to PostgreSQL. You will have to take the step before Zammad7 anyway. This content will be quite dry, but helps you to understand Zammad much better. Let's talk about the classic mistakes first. These are responsible for many of the issues you may encounter. The first mistake happens quite often. The number of the maximum possible connections your database server accepts is quite crucial. This configuration step is mandatory even for a vanilla installation. Tuning will worsen this situation if it's not adjusted. After a fresh installation, this limit by default is 100, which is not enough for a standard installation. We will come back to the reasons later on. A safe and working value should be 2000, even with fairly heavy performance tweaking later on. After adjusting the configuration file of your PostgreSQL server, make sure to restart it. As Zammad relies on a database as well, you should restart it as well. Make sure to restart the services in the right order. You can also add these optional performance tunings. They will require more memory from your host, but will improve your database reaction times on busier installations. You can ignore these if you want. Personally, I would implement them with 40 agents concurrent latest. By default, Zammad stores its attachments within a database. This is totally fine for small installations, which are not exactly busy. However, if you receive rather big emails and expect rather more traffic, you should think this one over. Zammad allows you to store these attachments to either your local file system or a compatible S3 host. For simplicity, we will choose file system here. Should you prefer S3 for whatever reason, consult the documentation which has you covered. Another side note when you choose the file system. If you are on a package installation, the number of small attachments in combination with big folder structures will be slowing down your update process. This is due to an enforced recursive change owner by Zammad's packager. You can overcome this by linking opt-Zammad storage to a different location outside the Zammad directory. All you need to ensure for this is that the files belong to the Zammad user. This example only works for empty storage folders. Proceed with care here. If you are using Docker-based installations, no matter if Docker Compose, Portainer or Kubernetes, ensure that the storage folder of Zammad is persistent. If it's not, a stack restart will cause a very uncomfortable data loss. Another quite usual problem that may occur is more of a configuration issue in Zammad. Many companies starting with a ticket system, no matter if Zammad or not, come from an email program like Outlook. Most users expect something like their trash folder for that reason. The argument is usually that they want to find freshly closed tickets in case they accidentally closed it. For this reason, many admins provide their users with an overview that basically shows all ever closed tickets. This is not a big issue in the beginning, but will be an issue later on. A good practice is to simply restrict this kind of overview to, let's say, 14 days. By this, your users will be able to see the last days of closed tickets. If they still have to look for a null ticket, they can always use Zammad's search function. If you want more in-depth input on overviews, you can check out my previous video. The last classic issue your user may experience is not too common, but may have a big impact on your user's browsers. In those scenarios, most often Zammad sees little to no system loads while your agents still have trouble with laggy browser reaction. Laggy means, for example, typed words taking their times to appear in a text area, settings not being applied immediately or generally delay in certain situations. This most of the time is being caused by Zammad's tabs on the left-hand side of the interface. By default, Zammad only allows up to 30 of these tabs to help the user keeping their overview, but also to ensure a proper browser performance. You cannot adjust this limit. Technically, however, a user can overcome it by having 30 tabs open. As Zammad can't decide if it can remove a draft on your tabs, they will stay. And this is where the issue comes in place. You can also check the actual number of tabs opened by the user by using the Rails console like so. If this number is around 30, you should be fine. If it's much higher, you may want to consider closing them for the user. Be aware that this is a destructive method and means that your agent loses all of their drafts. This should be your last resort. This kind of issue usually appears after adding new ticket attributes while a user has at least one ticket open. Zammad will notice that the default objects that should be there differ from the current tabbed version, and thus expect that it is handling a draft. This also applies if there were no actual changes before. Another remark on browser lagging apart from the taskbars. It's not always the tab itself, but sometimes also the sheer number of HTML constructs. Thus, this can also be caused by extremely long tickets with complex articles like a lot of quotation, or even many custom objects with tons of options to choose from. This technically isn't a Zammad issue, but a browser limit. Core Workplace may help you with the reduction of these. By default, Elasticsearch uses 50% of your system's available memory. This is not the best way to run Elasticsearch if it does not run on an independent machine. If all Zammad relevant services run on the same machine, this may cause unwanted out-of-memory situations and your operating system killing random processes. Giving your Elasticsearch something between 1 and 4 GB memory should be enough for handling. In a non-Docker environment, you can create the file Heap-Size.options within etc Elasticsearch jvm options d. The usage should be much better after an Elasticsearch restart. This adjustment is safe to do during business hours and only causes a minimal downtime of Zammad's search function. Before we can continue with the general performance tuning, we will have to talk about Zammad Processes. This will help you to understand the problems you may face better and thus on how to configure your environment correctly. All performance tunings highly depend on each instance. There's no rule of thumb because every instance is configured differently, each system behaves differently in terms of I/O, CPU times and storage speeds. Company rules in terms of how a system has to be installed may also be a factor. Performance tuning is always a process of fiddling, adjusting, close monitoring of the performance and further adjustment if needed. All additional processes you instruct Zammad to start extra should also have their own CPU core. If you overbook your CPU too much, you will not get any better performance at all. Source code and package installation users will only get in touch with the service Zammad. This service is actually a dummy service which controls the following service by default. Docker-based installations reflect the independent processes much more visible to the admin. By default, each Zammad process takes a pool of up to 50 database connections. This means that Zammad will require 150 database connections without any adjustments by default. Zammad-web is responsible for delivering all web app relevant things. This means your users, no matter of their role, interact with this service the most. Under the hood, this is one or more Puma processes. By default, there's one Puma cluster process being started. This is fine for small instances with 2 to 10 users, but will be an issue the more users Zammad has to serve at the same time. It also highly depends on the tickets your agents work on. The more assets Zammad has to load, the faster you will need more Puma processes. Performance issues with this process can be identified by permanent high load on Puma processes or when opening and updating tickets takes a long time. The most expensive situation in terms of loading times are agents that are logging in or reloading the web app. This may take a bit more time. Trying to tune Zammad for initial logins and reloading requires a lot of resources, which you may not need at all during normal operations. This last remark has been fixed with Zammad6, which uses significant fewer requests during the initial load. Zammad's background worker without further tuning is responsible for any scheduled operation, delivering overview updates, fetching email accounts and delayed job processing. Depending on the configuration and general workload, a single process may no longer be able to keep up. Especially in terms of email accounts, less is better. The more accounts you have, the more time Zammad will take to fetch them all. This will usually show in a background worker process that runs constantly on full CPU power, in combination with delayed jobs stacking up and overviews not reloading data in proper time period. Usually, overviews are being reloaded every 5 to 10 seconds for the last 5 viewed overviews. All other overviews are being reloaded every 60 seconds. While reloading solves missing information in overviews, during performance issues this is the worst thing your agents can do. It puts more load on your server. Zammad uses WebSocket connections to ship change data to your users. If WebSockets are not working, this will cause additional load and potential performance issues on your Puma processes. Your WebSocket process is also responsible for the chat functionality of Zammad. If you use Zammad Chat on your website, the chat applet automatically connects to Zammad and opens a WebSocket connection no matter if you automatically start a chat or not. For this reason, you may have to make this applet load only when the user really wants to use the chat. Right now, the WebSocket process is the only process you can't scale. Redis is a mandatory dependency for Zammad. It mainly is relevant for its WebSockets and data around this. We will ignore Redis in the further performance tuning. An optional dependency for non-Docker environments is memcached. It's holding your cache files within a system's memory if being used. This helps with rather slower storage systems and is required for container-based setups to allow sharing caches in between the containers. Now that we know how Zammad processes work and what they do, let's take a look at the available environment tweaks you can use to scale Zammad better. All these settings are update safe but not covered by Zammad's onboard backup and restore method. Source code and Docker users use their environment files. Package installation users can use the zammad config z command. Using zammad config get, you can also check the current value if any. To unset a current active tuning, use zammad config unset. After adjusting the performance tuning settings, you'll need to restart your Zammad instance. Let's take a quick look at the available environment settings. To allow more than one Puma process to allow more concurrent content delivery to your users, use web concurrency to adjust the number of processes to run as needed. Usually, if you're using the following tunings as well, this is still the setting with the highest value. A quick response of your web app is usually more important than a delayed job that takes a minute longer. If you require a lot of power to generate users' overviews, use Zammad Processes sessions jobs workers to exclude the session jobs process into its own processes. Use this with care and consider improving your overviews first. Reduce them to what you and your agents really need and ensure that you stay below 2100 tickets per overview. This environment variable was called Zammad session jobs concurrent and has been deprecated with Zammad6. Now, Zammad process schedule jobs workers is most likely only relevant for LDAP integration or users with high email traffic. This allows you to explicitly run all schedule jobs like fetching email, LDAP sync and cleanup tasks. If you're using this setting, you can only set this to 1. More than one process is not supported. If your main issue is rather Zammad not being able to keep up with delayed jobs and thus email sent out to customer speed does not satisfy you, you can use Zammad process delayed jobs workers. This will extract the delayed jobs from your background worker and allows running in up to 16 independent processes. In the new current developed version, there's a new additional tuning option. You can increase the default number of threads per worker by using Zammad process delayed jobs worker threads. By default this will be 1 and can be a maximum of 16. It will be available with the next stable release, most likely Zammad7. Besides Zammad process session jobs workers, this is most likely the most CPU intensive process in Zammad. The last environment setting will be available with the next upcoming stable version. This will most likely be 7.0 but might also be a 6.6. It affects the upcoming AI tasks that need to run in parallel and are more of a waiting nature. By default it's part of Zammad's background worker, but can run in an independent worker process by using Zammad process delayed AI jobs workers. Like the processing of delayed jobs, you can also adjust the number of threads with Zammad process delayed AI jobs worker threads. The default number of the threads is 5. You can set it to a maximum of 16. Please note that the setting highly depends on the AI service you're going to use. Too high settings can actually overload the AI service and might cause problems. Now let's come to one optional dependency you can use to reduce disk I/O and potentially scale with several machines. Docker-based installations have the following as fixed dependency. By default, Zammad writes a lot of cache files into its temporary directory. These cache files help Zammad's performance, that is as long as your file system can keep up. Use memcached_servers to configure Zammad with memcached. After you have configured your environment, make sure to restart Zammad. I hope that this video helped you to understand Zammad's processes and tuning options better. Until next time, take care.